Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 10, 2025, just yesterday. It introduces a system that can turn ordinary single-camera videos into high-quality stereo footage, with much better visual fidelity and 3D geometric consistency than previous monocular to stereo pipelines. The paper is titled StereoWorld, Geometry-Aware Monocular to Stereo Video Generation. And as we will see later, the implications for extended reality video production are quite significant. Figure 1 makes that idea concrete by showing how a single flat video becomes an immersive stereo experience. The left panel shows the original monocular video that a creator already has. The center panel shows the generated right eye view, which pairs with the original to form a stereo pair. On the right, the figure illustrates applications, including colored anaglyph glasses and modern extended reality headsets that display the converted stereo video. Table 1 makes the data story concrete by showing how unusual it is to have a large stereo dataset that actually matches human interpupillary distance, which is the spacing between our eyes that stereo cameras should mimic. The upper rows list existing benchmarks across optical flow, driving, robotics, and movie domains, and they mostly lack interpupillary distance alignment. The cells on the right show that even the few interpupillary distance-aligned movie sets are not publicly released, and are quite small. The final row highlights StereoWorld 11 million, which is both interpupillary distance-aligned and publicly available with about 11 million frames, so it fills a major gap for training and evaluation. Figure 3 explains why disparity alone is not enough to supervise stereo generation. The top two rows compare the left and right eye images, and the red and blue boxes highlight regions that only one eye can see because the camera moves sideways. The bottom row shows disparity maps, which only exist where both views overlap, so they give no signal in those occluded areas. This gap is what motivates adding depth-based supervision that still constrains geometry everywhere in the scene. Figure 2 lays out how the system turns a single video into a geometrically consistent stereo pair. The full diagram shows training at the top and inference at the bottom, which makes clear that only a monocular video is needed at test time. On the left, the model ingests left and right views plus a depth map and converts them into latent codes. The central shared DIT blocks process these latents jointly so that space, time, and viewpoint information all interact. On the right, specialized RGB and depth branches, together with a stereo projector supervised by disparity maps, teach the network accurate three-dimensional structure before it finally outputs the right eye video during inference. Alright, to wrap up, the key idea is that StereoWorld turns ordinary single-camera videos into high-quality, geometry-aware stereo, thanks to joint disparity and depth supervision, plus that massive interpupillary distance-aligned dataset. That unlocks cheaper, more reliable, extended reality content creation at scale. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.